All right, this last video for Unit 7 is going to be looking at acid-base behavior and how it relates to the chemical structure of the molecule that we're looking at. And specifically, we're going to talk about oxyacids and then oxides. So both having to do with oxygen with a little bit of difference. And so as it says here, what are the two factors that determine whether a molecule containing a bond between an atom and hydrogen will behave as a Bronsted acid? And the answer to that question is either the strength of the bond and or the polarity. In the first case, the strength of the bond, weaker bonds are going to be more acidic, and the polarity, more polar, means more acidic. So, for example, this goes back to the acetic acid example that we had looked at earlier in the unit. Let me just draw the Lewis structure. The bond between carbon and hydrogen is strong and it's relatively nonpolar, and so they don't have a tendency to donate a proton at all, which is why when you look at the formula for acetic acid, it's going to be this hydrogen or this hydrogen that gets donated, because these bonds right here between the carbon and the hydrogens are all relatively nonpolar and they are quite strong, and so they really are going to have no tendency for these hydrogens to be donated. So it's going to be the one at the end. The next section is looking at the strength of oxyacids. So an oxyacid is just any acid that contains oxygen. And the trend is that as the number of oxygens increases, the acid strength is going to increase. And the reason for that is because oxygen is very electronegative, and so it's used to draw the electrons away, which then polarizes and in turn weakens the OH bond, making it to be more acidic. When this happens, a proton is then easily removed from the molecule with the largest number of attached oxygens. Again, more acidic. And then the same reason, for this same reason, it's why hydrated metal ions become acidic. And that was mentioned in an earlier video. We talked about hydrated metals. And then the greater the electronegativity of the attached ion, the stronger the acid, because the electronegativity of the strong atom is going to pull the electrons away from the other substances, and when that happens, it weakens the bond. So with questions relating to this, it's going to be pretty typical to see these as multiple choice questions because they're very conceptual. They don't require any calculations. That's all just ideas that lend themselves really well to multiple choice type questions. So here's an example, some examples of oxyacids. So if we look at the first section, so comparing chlorine, so you have hypochlorite, you have chlorite, chlorate, and perchlorate, and you can see by looking at the Ka values, as the number of oxygens increases from 1 to 2 to 3 to 4, the Ka value gets much larger until you reach the perchloric acid. That's the strong acid. And you could look at these two examples for the sulfate and sulfite. Sulfate has more oxygen, so it is a much stronger acid than sulfite. And same with the last two, looking at the nitrogen, nitrate and nitrite. So more oxygens is more acidic. That's the general trend. It's also important to be able to compare the electronegativity, because if we are being asked to compare these four acids, all of them have the same number of oxygens, and so that may be a difficult thing for you to look at. You can't just look at which one has more oxygens and say that one's more acidic. So instead, we're going to compare the electronegativities of the element or the group of elements that is not oxygen or hydrogen. And so in the first case, we have chlorine, bromine, iodine, and then CH3. So if we compare the electronegativity values of those four things, and as it says here for the last one, we're going to use carbon when we're looking at CH3. As the electronegativity decreases, you can see the Ka also decreases. So as the electronegativity of X decreases, the Ka also decreases, making it a weaker acid. So if you were to put these in order of increasing acidity, we would say that this one is going to be the weakest, followed by this one, followed by this one, and this one. And then again, this is the trend. So as the electronegativity of X, whatever that X is, so that's the non-oxygen, non-hydrogen element, decreases, the Ka value is also going to decrease. And finally, the last bit of information from this unit is looking at oxides. And so this should probably have gone before the last slide. But here's some more information as to why things with higher electronegativities are going to be more acidic. So this is your acidic, and this is your basic. So if X, the non-hydrogen or oxygen element, has a high electronegativity, then the O to X bond is going to be relatively covalent and strong, meaning the hydrogen is then going to be released. Because if you look at this, if this bond is particularly strong, that means your hydrogen is going to be released, which is the characteristic of a Bronsted-Lowry acid. And then in the other case, if the X element has a low electronegativity, then the bond that's between the oxygen and whatever the X element is going to be ionic. And then when that happens, it can be broken into polar water, and then a hydroxide is going to be released. And so here is just a general statement about basic oxides and acidic oxides. So when a covalent oxide dissolves in water, it's going to form an acidic solution. And then if you have an ionic oxide, so a metal oxide, when it's dissolved in water, it's going to be a basic solution. So here are two examples. SO3, this would be a covalent oxide. When it's dissolved in water, it's going to produce an acidic solution, whereas when a metal oxide, calcium oxide, is dissolved in water, it is going to produce a basic solution. So these are two different categories of oxides. One is looking at whether it's a covalent oxide versus an ionic oxide, and the other one is looking at the electronegativity of the non-oxygen and non-hydrogen element. And that is it for the Unit 7 notes. This problem set here that's mentioned, I will give it to you in class, and we will probably work on it together. But it will still be due with all the other problem sets. And that's it for Unit 7.